Good morning, guys. Hope you're doing well. This will be the first lecture, official lecture for 111. I'm going to do some introductory stuff first, probably make that a separate recording, and then I'm going to talk about the actual material from chapter 14, which is chemical equilibrium. So I'm going to share my screen so that we can do that, and hopefully you guys will be able to hear and see everything that's going on. So again, this is the first lecture out of that. We'll talk about our intro stuff first, and the first introduction I need to do is me. So I'm Dr. Nanette K. Hartley. I prefer Dan. I got my undergraduate degree at University of California, Riverside with a BS in chemistry. I did graduate work at Arizona State University, where I got an MS and a PhD in analytical chemistry. I started teaching at Iowa State University. I then went to ASU, then U of A, then Maricopa Community College, then Scottsdale Community College, and then to Trident Tech. I started teaching at Trident Tech in 2013 and have taught on and off since then. My office is in Building 970. It's 302L. My name is not on the list yet. If you come to see me in person, you'll need to dial my extension to be able to get to me. My office is where Professor Twinter's office is, but my extension is 6699, so you'll need to dial that, and then I can come collect you and bring you down to my office. My office hours are Monday through Thursday, 12 to 1 p.m., and by appointment. Those office hours are both virtual and in person. I will show you the link to the virtual in just a few minutes. My phone number is 843-854-6699, and my email is nanette.hartley@tridenttech.edu. So that's all the information you probably might need about getting a hold of me. So the other thing that I like to do when I'm in a physical class is do an introduction with my students. I like to know a little bit about my students before we get going. I'm going to continue one part of this, and you'll see that the last thing that's on here, it says word. So I ask my students to give me one word to define themselves. I provide them the same thing, and my word is stubborn. So I can be very stubborn, and that can get in the way of my ability to talk to my students sometimes. So if I'm being stubborn and I'm not listening, please feel free to let me know that that is the case. I am not going to be upset, or at least if I am, I won't direct it at you. So that is a little bit about me. Now, the syllabus has been uploaded to D2L. My addendum is also on D2L, as well as the course policies. Now, I need to mention something about the syllabus. If it's in the department syllabus, it's law. I cannot change anything that's in there. So I cannot make any changes to that. That does mean that there will be no extra credit. Let me show you the D2L shell so that we can talk about this a little bit. So this is a shell for our course. You'll see the course announcements. In here, there is a thing that says office hours, and there's a link right here. This is a link to my virtual office hours. Okay, so those are available Monday through Thursday, 12 to 1. I also have a block on Thursday from 8 to 10, which I have not listed here, but that is also the case. A couple of other things I need to show you in the D2L shell. In the content, there are 3 separate areas that are pretty important in terms of what you need for the class. Now, a bunch of this stuff is just for reference, if you need additional help, things like that. That's all the stuff from material from Professor Twinter and below. The things you really need to know about the syllabus and schedule includes an introductory video to the overall structure of the class, the department syllabus, which is this right here, my syllabus addendum, my course policies, and the schedule for the class. I'm going to go ahead and open the schedule so we can talk about this. You'll see that there's a lecture number, the topic that we're going to talk about, the chapter and sections out of the textbook that refers to, what the sections in ALEX are called that go with that lecture, the approximate date that we should be talking about those materials, and the recommended due date. So everything that's for test 1 in ALEX, which I'll go to in just a second, is not due until 2 days before that first test. And if you scroll down a little bit, you'll see that that first test is 6/17 through 6/20. That means that all of the assignments for Unit 1 are due by the 15th. Now, that does mean that we're only going to be talking about lectures 1 through 4 on exam 1. And you will see that if you come back to this table of contents and go to the actual structure for the course, you'll see there's a unit 1, unit 2, and unit 3. In unit 1, you'll have chemical equilibrium, acid-base definitions, titration, and Lewis and precipitation reactions. Those are the only things that are covered on that first test. So we start on the unit 2 materials before the first test, excuse me, to give you a little more time to get all of the information that you need for the test into your brain. So let's go take a look at Alex so I can show you a couple of things in Alex. Now, if you haven't found the link to Alex yet, it's on the MH campus/connect. I apologize. And it's this Alex button here. Now this is going to take me into the instructor view. I'm going to go ahead and switch to the student view to show you what this will probably look like for you. Should look like for you. And you should see something that looks like this. You'll see that there's experiment 1 equilibrium is due today by midnight. That's a lab assignment. You'll be able to see what else is coming up that's due. You can click right here or on this 3-line thing to get this expanded view. In this expanded view, there are 2 things that I want to point out. One is the assignments and one is the textbook. Let's do the textbook first so that we can get that over with. So if you click the plus next to textbook and click on the ebook, that'll bring you to the electronic version of the text. This will take you to any part of this textbook. You can go to the table of contents. We can go and look at the chemical equilibrium. You'll see that there are sections 1 through 5, which we do cover all of them in this class. If you need to get to section 14.2, you can click directly into that. So that's how you can get to all of those materials. Okay. So that's the Alex portion. You can also get to the assignments. When you come into this assignments thing, you'll see that there are labs, which are these guys right here, and homeworks. Now you can filter this so that you're only looking at labs or homework. So I'm going to filter to the homework. You'll see that all of these that are here are related to that first test. Now the common ion is actually something from the second test, but its due date is right before the first test. Now, that material is not going to be covered on the first test, but all of those are due before that first test, and it's 2 days before. Since you have I think it's actually a 3-day window for the exams, unless you have some really horrendous written excuse that for why you can't take it during those 3 days, there will be no extensions given on when that test can be taken. A couple of other things about that. Because you have all of this time to complete the Alex assignments, I will not be granting any extensions for full credit. Now, you will see over here that you have time beyond that first test to turn it in. So if you, for whatever reason, can't do it before the first test, and you need to turn it in after the fact, you can do so. You will receive at most 60% of what it's worth, but that can be turned in up to 8/5, which is 2 days before the end of the class. A couple days before the end of the class. Okay? All right. So there's also the prerequisite review. This will give you an idea of how you're doing with the material that you need to know from other places. Math, physics, that kind of stuff. So that's everything in Alex. Like I said, you will not get a lot of extensions for this. Now, while we're talking about tests, I want to show you in D2L where that's going to exist. Your tests will be under quizzes. They will eventually show up right here. You'll need the lockdown browser and Respondus monitor to be able to take them. Okay, so you need to make sure that you've done this test to make sure that you can actually use your computer to do that. You need to do that before the test is due. I'm not going to have a lot of sympathy for people who need an extension because they didn't take the, pre-test to make sure that they could take the test in here. Okay, so there will be unit tests that are in here. They will be available to you for a few days. They will use exam handouts, which are not posted yet, but which will be posted right here, you're expected to print those handouts to use with your test. Now, when you take that online test, you'll need to show me the exam handouts front and back to make sure that there's nothing written on them. You'll need to show me whatever you're using for a calculator. Please understand, you are not allowed to use a phone for your calculator. You cannot do that. You have to use a calculator to do it. Okay? So that is something that you need to be aware of. We do have people who check those videos to make sure that you're following the rules. All right? So that is something that happens. Oh, that was the other thing. Your tests will expect that your scratch paper will get turned in. That will get turned in under assignments. You'll see that there's one for each test and the final. I'm expecting that those get turned in. Now, having said that, you will be expected to enter the final answer into D2L, and that will be graded. So your preliminary grade may give you a grade for that particular answer. But if your scratch work does not show how you got that answer, if you do not show me the process that you used to get that answer, then you get no credit. I am not concerned about whether or not you got the right answer. I'm concerned about whether or not you know how to get it. So I need to see your work to show me that. One other thing I will warn you about. If I see numbers with no units, I will freak out and you will lose points off your test. Okay? A number without units is meaningless. So you need to make sure that you've shown that. All right. So I think that's everything I had to show you about those. Now I'm going to show you one other thing in the content section in case you haven't watched the introductory video. All of your materials for the class are in this Chem 11 lecture summer 2022. You'll see that this is Unit 1. There are 4 topics here. Right now, each topic contains 2 items. As we move forward over the next week, everything will get 5 items in it. What are those 5 items? There is a list of the lecture topics. And I'll show you one of these just to show you what's in it. So there's the topic that we're talking about. What slide set it's in. The slides that actually cover that. And then the parts of the textbook that cover that too. So there's correspondences there. Now, it's written this way because eventually, when we get to the first test, I'm going to combine all of these lists so that they're in one exam topic list. And then you will have all of the information about which lecture it was in, which slides it was, yada, yada, yada. So that's that. There's a lot more detail presented here than what is presented in the PowerPoints. But let's talk about the PowerPoints. The second thing you'll find is the PowerPoints. It's a PDF document, but they are the PowerPoints that I go through. So these are the PDFs for the lectures that you'll be seeing. Once the lecture is recorded, you will find a link to it right here. Okay, so it'll be the third item in there is the lecture itself. So you'll have that. Then there are going to be 2 other things that will appear. One will be a practice sheet, so you're practicing the topics from that particular lecture. And one is the answer sheet to that practice sheet. Now they're presented in 2 pieces for a reason. I want you to try those practice questions on your own without the answers. Then look at the answers to make sure that you know how you got there, what you did. I do tend to give more than just an answer. I do tend to give some explanation as to how I got it or why I got it or whatever. So make sure that you refer to that. And if you have any questions, comments, problems about anything that you see in the lectures, the videos, any of it, whatever, please let me know. Contact me via email, via phone, whatever. Just let me know what basic area we're talking about, i.e. was it the topics, was it the lecture, was it the PowerPoints, was it a practice sheet, what issue what issue you have with that. And I'll do my best to answer that. If we need to, we can set up some time for us to talk virtually or in person. Okay, so that's everything that exists in D2L that you need to be aware of. I do expect that at some point you will read the syllabus for the class, my addendum, and the course policies. I do expect that will happen. Okay, so if there are things that are in there that you need to know about, then you should have read those. All right. Trying to think. I think that's everything for the introductory portion of D2L. So I'm going to go ahead and close out this tab. And then I'm going to leave those there for now because I'll need them later. Let's go ahead and see what else we have in the beginning of this lecture. Now, we are going to be talking about chemical equilibrium today. But before we get to chemical equilibrium, we need to talk about what else you need to know. 111 is based on 110. So the second half is based on the first half. That means that anything that we cover in the second half probably does relate to something we talked about in the first half of the class. So there is an expectation that not only do you know those topics, but that you can work with them in a fairly, comfortable way. To take a look at that, I want to show you something that I provide my 110 students. As we go through the course, we talk about the mass of things, converting that to moles, converting that to number of particles. We then can talk about using the density to find the volume of the solid. We find ways to talk about with the molarity, what's the volume of the liquid that's present, or the volume of the gas that's present. So all of those calculations can be done. And of course, we can talk about going from this particular substance A, be it a product or a reactant, doesn't matter, and going through the stoichiometric factor from the balanced equation to get to something else. So we can talk about another reactant or another product. All of that is based in a balanced chemical equation. I say that because you need a balanced chemical equation for everything that we do in this class. Everything we do is dependent on those equations and how they're balanced. So that's our review. Fabulous. Oh, you didn't think we were done, did you? Nope, we are not. So now we're going to spend a little time going through 4 questions that are based in materials out of 110 that I think you should be able to handle at this point. So they're multi-part questions. I have this written over on one side, so I'm going to pull up a piece of paper to show you what I write down, my calculator, and a couple of the tools that I use when I'm doing these problems. Okay, so that's going to be what happens. So that's my fancy piece of paper. That's my calculator. And then we have a periodic table and a molecular mass calculator that we use as well. So let us consider these questions that we've been asked. Now, since this is asynchronous, what I'd like you to do is to attack each of these questions on your own. See what you can do with the information that's provided. See if you can solve these problems and answer all of the questions that have been given. If you can, great. If you can't, okay, we can talk about that. But I'm going to show you how I do this so you can see, 1, my problem solving method, 2, the kinds of things that I write down, and 3, everything that I spit out and throw around when I talk about these things. Okay? So our first question says 4.2 grams of magnesium is added to 13.56 grams of HCl dissolved in 0.25 liters of H2O. What is the balanced equation for this reaction? How much product is formed? What is the limiting reagent? How do you know? And what kinds of reaction is this? All right. I have some information. I need a balanced equation. So I know that I'm reacting Mg with HCl, which has been dissolved in water. So the Mg is a solid, the HCl is aqueous because it's been dissolved. This is a single replacement reaction. So I'm going to take this H plus and replace it with the Mg2 plus. Now it's Mg2 plus, and remember that comes from the placement in the periodic table. So Mg is here. That means it has 2 valence electrons. It wants to have 8. So the easiest thing for it to do is to lose 2 to come back to the neon configuration, which gives it 8 valence electrons. So it's going to be an Mg2 plus since it's lost 2 electrons. Let me show you my paper again. So that's an Mg2 plus with the Cl. So I'm going to need a Cl minus. That means I need 2 of those. It's aqueous. Plus an H2. Now, how do I know that it's H2? Well, let's talk about that too. There are 7 things that occur in nature as diatomic gases. So hydrogen is one of them. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are the other ones. Now, I like to remember that because it's a nice little structure right here. It looks kind of like a 7, but 1, 2, 3, 4, 5, 6. Oh, there's 7. That's the H. So all of those appear as diatomics in nature. So that's how I know it's going to be an H2. All right, so here's my equation, except it's not balanced. And I know it's not balanced because I have 2 chlorines on this side and only 1 on this side. And I also have 2 hydrogens on this side and only 1 on this side. So if I put a 2 in front of the HCl, that means that I then have 1 Mg on both sides, 2 H's on each side, 2 Cl's on each side, and that therefore is a balanced equation. Now, I know that I'm going to have to do some manipulations with these to get to moles, right? I know that's what I'm going to have to do. Everything goes through moles. So I'm going to use a molecular weight calculator to find out what the molecular weight is of each of these species. On a test, this is exactly what I do. I have 4 species that I may or may not need to talk about. I want to know what their molecular weights are so that I can do calculations with that. So Mg is 24.31. I'll show you where I'm writing this down in just a minute. HCl 36.46. MgCl2 95.21 grams per mole. And H2, which is actually going to be 2.02. I know that one, but now, do I know how to calculate a molecular weight? Absolutely I do. But I get really tired of having to write all that stuff down when there is a calculator that I can use online to be able to do this. This is a Lentech molecular weight calculator. If you search Google for a molecular weight calculator, you'll find those ones. There are other things in here too, but this is primarily what I use this for. So I wrote all of those molecular weights above each of the species because I may or may not need to use them. I prefer to write all my molecular weights down at the beginning and then work with them if I need to. So let's talk about how we do that. So I need to convert this 4.2 grams of Mg to moles of Mg, from moles of Mg to a product, because I know I have 2 products. And it wants to know how much product is formed. So it doesn't ask me for a specific product, so I can choose either one of those 2 products to talk about. And it doesn't specify how I have to report that number to do the comparison. So in that case, because it hasn't specified any of that, I can report it in terms of moles of a product or grams of a product. Now, me being me, I do better with grams, so I always convert to grams. So I'm going to go from grams to moles to grams. We're going to start with 4.2 grams of Mg. I know that there are 24.31 grams of Mg per mole of Mg. I know that there is 1 mole of Mg. And I'm going to do this in terms of H2 for what to use to make 1 mole of H2. So 1 and 1. I know that 1 mole of H2 is 2.02 grams of H2. And so I can do some happy math with that to determine how much I can make. 4.2 divided by 24.31 times 2.02. And that gives me 0.348. But since I only have 2 sig figs in the mass of the Mg, I can only report my answer as 2 sig figs. 0.35 grams of H2. Now remember, just because I'm reporting that answer as 0.35, if I'm going to do anything with that calculation, I need to remember to use all of those digits that are present so they don't get rounding errors. Okay? So that's my calculation using Mg as my starting material. I need to do the same calculation with the HCl because I don't know which one of these determines how much product I can actually form. So I need to calculate which is the lower production because that's my limiting reagent. So I go through a similar calculation, 13.56 grams of HCl and 36.46 grams HCl per mole of HCl. 2 moles of HCl make 1 mole of H2. 1 mole of H2 is 2.02 grams. So I've gotten rid of the grams of HCl, the moles of HCl, and the moles of H2 to give me grams of H2. If I do that math, 13.56 divided by 36.46 divided by 2 times 2.02, it gives me 0.37. Now, for those of you who may not know what this math thing is, this train track that's set up here, anything that's above the line, I multiply. Anything that's below the line, I divide. This is the way that I keep track of things. Notice that the units are included. That's called the factor label method, because if I include my units and I get the right units out at the end, then chances are I have the right number. This is literally how I passed physics, was just knowing what units I get to. Excuse me, sorry, just a second. So I need to make sure that my units are correct. So that's why I include the units when I do this. And this is the way you'll see me write all of this stuff. Now, do I expect you to do that? Absolutely not. You can do whatever kind of math you want to be able to show this, as long as I can follow it and there are units included. And you show me something. So reporting this as 4 sig figs, because I have 4 sig figs in the 13.56, I get 0.3756 grams of H2. That number is larger than the one that I calculated previously, so I know that my limiting reagent is the magnesium. That determines how much product I form. How do I know that that's how much product I form? Because it's the smaller of those two values. Now, it may be less than that. That's my theoretical yield, is what I've calculated here. And it may not be actually that much that I generate out of this. But that's the maximum that I could get from this reaction. Okay? And I told you, it's a signal replacement reaction. So that's the work for that one. Now I'm going to get a new piece of paper, and we're going to get started on this next one. Bear with me just a moment. Okay, so now I've done that particular question. Let's talk about the next one that we have. I have 15 grams of barium hydroxide added to 1 liter of water and reacted with 15 mils of 0.25 molar nitric acid. How much what product are formed? So 15.0 grams barium hydroxide. And again, I know that barium is on the periodic table, right? Here, that makes him a 2+, therefore I need 2 OH- to make that neutral, so that's a BaOH2. That is added to 1.0 liter of water. I then add 15 milliliters, and it's 15.0. 0.25 molar HNO3, nitric acid. Now, do you need to know that nitric acid is HNO3? Yes and no. There will be a list of common names and their formulas on the test. You will be able to see those exam handouts before the test. Those should be posted early next week. So you will be able to see what exactly you're going to get, and therefore you'll have some idea of what you need to know and what you don't. I want to know what products are formed, so I need a balanced equation. Barium hydroxide is a base. I'm adding an acid to that. So I know that I'm going to form water and a salt. I know that I have 2 hydroxide units here, so I need 2 acid units to react with that to give me 2H2O plus BaNO3, 2. This is a liquid. This is going to be aqueous. This is aqueous. And this is aqueous. Okay? So that's what we're talking about there. Those are my products, water and barium nitrate. Now, I don't really care that much about water because there's tons of it around, so I'm not that concerned about it. I want to know how much of this barium nitrate that I made. So let's go look at our molecular weight calculator so that we can talk about molecular weights for these guys. EaOH2, 171.34. HNO3 is 63.01. Water should be 18.02. And BaNO3, 261.34. Now, one thing I'm going to mention to you, you are given a periodic table to use on the exam. If I see numbers that are different from what I see on that periodic table on the exam, that's going to be a problem because that's the one you should be using on the test. You shouldn't be using whatever's in your calculator or whatever's on your phone that you looked up. That's cheating, okay? You have to use the one that's on the periodic table that you're given on the test. So that's what should be there. And therefore, we shouldn't have any errors that come from us calculating different weights by using different tables because they're not consistent across different tables. So now I have 15 grams of BaOH2. And I need to convert BaOH2 to moles. I'm going to divide by the molecular weight. I have 1 mole of BaOH2 reacting with to give me 1 mole of BaNO3. And then I want to convert that to grams because that's how I do things. So 1 mole of BaNO3, 2 is then 261.36 grams. And again, I can do happy math with that. As long as my calculator doesn't blow up, I should be okay. And I did the math for it. Go. 15 divided by 171.34 times 261.36. When I saw that my number was huge, I knew that I'd done the math wrong somewhere. So my calculator did blow up on me because I didn't enter the numbers right. So that gives me 22.9 grams of BaNO3. I could calculate the amount of H2O as well. When I was a student, I would have done that just because I didn't know exactly which one they wanted, and so I didn't want to be in a place where they go, "Oh no, it's not the one I wanted," and I didn't want to have to argue with them. So I figured if I calculated them both, then I would be fine. I don't necessarily expect you to do that. You have to answer whatever question I ask you. And so if I don't specify what product I'm looking for or in what units I'm looking for it, you can tell me the number of moles of whichever product you want, or you can tell me the number of grams of whichever product you want. And that will be what is looking for. We now need to do the same thing for our other material. But what I have for my other material is a molarity, which is moles per liter. Now I need that moles, but I need to get rid of the liters. So I have a 0.25 moles HNO3 per liter. I have 15 milliliters that I'm working with, but that's not the right unit. So I have canceled all of that to leave you with moles of HNO3. I know that there are 2 moles of HNO3 required to make 1 mole of BaNO3 2. And again, I'm going to multiply by the molecular weight to get me a mass of that material that's made. So I know that I started with moles per liter. I know that I needed to get rid of the liters, but I only had milliliters to start with. So I multiply by the milliliters and then convert it to liters. Then I do the molar ratio, and then I multiply by the molecular weight of the BaNO3. So 0.25 times 15 divided by 1,000 divided by 2 times 261.36. That gives me 0.49. And that's 2 sig figs because that my molarity is only 2 sig figs. And that's grams of BaNO3 2. That means that by a long shot, my HNO3 is my limiting reagent. And so that's how much of what product is formed. Okay. And again, I calculate how much water is formed from that as well, knowing that that's the limiting reagent. I could set this up, but instead of having the 1 mole of NO3 here in the molar ratio, I would put the 2 moles of H2O there and then multiply by the molecular weight of the H2O to calculate how much product I make. Okay. So that's that question. Yay, 2 out of 4. Awesome. Give me just a second and we'll move on to number 3. So my next question says 15 grams of sodium hydroxide. Oh, sorry. Bear with me, I hit the wrong button, I apologize. So 15 grams of sodium hydroxide and 15 grams of magnesium chloride, we determined that was MgCl2 before, are both added to 0.05 liters of H2O. Solid forms upon mixing. How much of what solid is formed, and what is the limiting reagent of this reaction? Okay, fine. So let's look at our table again. Sodium hydroxide is 40. No, hold on. Let me show you my hand scratching. So sodium hydroxide plus MgCl2 goes to give me NaCl. Na is plus, Cl is minus. I know that since I have 2 Cl on that side, I'm going to need 2 of those, which means I'm going to need 2 NaOH. and then I have an Mg, which is 2 plus OH2. So those are my products. That's my balanced reaction. I know that both of these are aqueous. This one is aqueous, and this one is a solid. Now, how do I know that? Well, that's because I know the solubility rules. Do you need to know the solubility rules offhand? No, you do not. They are given to you on the test, but you need to know how to apply them to figure out which one of these things is going to be the solid. Right? So that's something you need to know. If MgOH2 is a solid that I formed, I want to know how much of that I formed. So I'm going to set up all of my calculations to go to MgOH2. I'm going to start with 15.0 grams of NaOH. And I was finding out what the molecular weights of these were. And I know I found that that was 40. So MgCl2 is 95.21 grams per mole. NaCl, doesn't parse right, and is 58.44. And the MgOH2 is 58.32. So I'm going to divide by the molecular weight of the NaOH. 40 grams and 1 mole of NaOH. I will... Sorry about that. We were taking and looking at converting the grams of NaOH into moles of NaOH. So we've converted from grams. We now have moles of NaOH. I know there are 2 moles of NaOH per 1 mole of MgOH2. And I know that 1 mole of MgOH2 is 58.32 grams. So we get happy math. Let's find my calculator. 15.0 divided 40 divide 2 times 58.32. And that gives me 10.935. Looking at my sig figs, I have 3 sig figs in the NaOH. So 10.9 grams of MgOH2 are formed. I also have 15 grams of MgCl2. 1 mole of MgCl2 is 95.21 grams. I know that 1 mole MgCl2 is required to make 1 mole of MgOH2 and 1 mole MgOH2 is 58.32 grams. So again, happy math there. 15.0 divide 95.21 times 58.32, and that gives me 9.17 grams. OH2. This being the smaller number is going to be my limiting reagent. So I know how much of what solid is formed and what the limiting reagent is. Let me get a new piece of paper. And we'll look at the 4th question here. 15 liters of hydrochloric acid gas at 42 degrees C is added to 15 liters of room temperature ammonia gas. What are the products of this reaction and how much of them are formed at STP? So I have 15 liters of HCl gas, 42 degrees C, added to 15 liters ammonia gas at room temp, which is 23 degrees C. I want to know how much of what are the products and how much do I make at STP. Now, STP is defined as 1 atmosphere and 273 Kelvin. I know that in order to work with these temperatures, I'm going to convert them to Kelvin. So 42 plus 273.15, 315.15 Kelvin, and 23. 273.15 plus 23 is going to give me 296. Now, I have volumes, I have temperatures, I have pressures, and I have gases. That implies to me that I need to be working with the ideal gas equation, which is PV equals nRT. Now, does that appear on your test, the equation? Yes, it does. Absolutely it does. But you need to know what it is and what it's used for. Now, I want to know the way that this always works is we have to work with moles of one to moles of another, right? So first I need to figure out what my products are. So HCl gas plus NH3 gas is going to give me NH4Cl. Now, if this was in solution, it'd be NH4 plus Cl minus, but this is a gas because we're all in the gas phase. So it's this NH4Cl. It's a combination reaction. We make one product. Okay. Now, am I going to have to do a mass conversion? So do I need a molecular weight? Answer is no, because I have liters. So that means I need to use PV equals nRT to figure out what the number of moles of this gas is. So if I'm looking for N, that's equal to PV over RT. My pressure is 1 atmosphere, because I didn't see anything that says that the pressure changed, and I know my N conditions are 1 atmosphere. So pressure is 1 atmosphere. The volume that I was given is 15.0 liters. R, 0.0821 liters times atmospheres per mole times Kelvin. I'm pretty sure that's given to you on the test as well. And the temperature that I calculated is 315.15 Kelvin. Now, this has to be in Kelvin. Almost everything that we do with gases is in Kelvin. And I know it has to be in Kelvin because I have Kelvin present in my R. So if I want N, I need to multiply this 1 atmosphere times this 15.0 liters. I need to divide by the temperature, 315.15 Kelvin, and I need to divide by R, 0.0821 liters times atmospheres, mole times Kelvin. Now, the Kelvin cancels, the atmospheres cancel, the liters cancel. That leaves me with an answer in moles, which should be correct. Now, 1 atmosphere times 15.0 liters divided by 315.15 divided by 0.0821. And that gives me 0.579 mole. Now, how do I know that that's 0.579? Well, let's talk about this. I have 3 sig figs that were given here. Oh, actually it's not. It's 5.8. I have 3 sig figs that were given in the volume that I was given. 2 sig figs in the temperature. Okay. Now, when I did the conversion, I added those other numbers to it, but those are not actually significant. Okay. I know that the 1 is statistically infinitely significant. Okay. It's a conversion factor, and therefore we're not worried about that. So the 42 degrees is what's limiting the number of sig figs that I have. So this is the number of moles of HCl that I'm working on. I can do almost the exact same calculation for the NH3. We're still at 1 atmosphere. This time we're at 296.15 Kelvin. I still have 15 liters, and I'm still dividing by R. Kelvin cancels, liters cancel, atmospheres cancel. That leaves you with an answer in moles. So again, 1 times 15 divided 296.15 by 0.0821. And that gives me 0.62. Now, let's look at this balanced equation that we have right here, right? We know that this is a one-to-one relationship. 1 HCl plus 1 NH3 goes to 1 NH4Cl. So if I have 0.5 moles of HCl and 0.62 moles of NH3, the lower number is the 0.58. Okay? And if I have 0.58 moles of HCl, that's also going to be 0.58 mole of NH4Cl. Now again, no different units are required for this, so I could stop there. The products I've been is NH4Cl. How much is formed? I get 0.58 moles of NH4Cl. Since they gave me STP, I know that I'm supposed to I know because I wrote this, that I'm supposed to convert this to a volume. All right. And if I were going to do that, I would use PV equals nRT. Volume is equal to nRT over P. I know that N equals 0.58 moles. I'm sorry. Temperature is 273 Kelvin because I'm an STP. P equals 1 atmosphere because I'm an STP. R equals 0.0821 liters atmospheres per mole Kelvin. And so my V is going to be 0.58 mole. 0.0821 liters times atmospheres mole times Kelvin. I know that I have 1 atmosphere, and I'm going to put that there just so I can save a little space. And I need to multiply that by the 273.15 Kelvin. That will leave me with an answer in liters, which is what I'm looking for. Now remember, we talked about this before. I have to work with this big number that's right here so that I don't end up with rounding errors. So to get back to that, I had 1 times 15.0 divided 0.0821 divided by 315.15. That gives me that lovely number there. And multiply that by 0.0821 and 273.15 and divide that by the 1. And that gives me 13 liters of NH4Cl created. Dun 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 dun! We're done with our review. Go, awesome. That's really cool. Now, is there anything else that I'm asking you out of the review? No, there's not. So what I'm going to do is take us back to our PowerPoint and go to the next slide and say, do you have any questions? Now, at this point, I'm going to go ahead and pause and start a different recording so that we can talk about chemical equilibrium from this point. I just want to make sure that it's not too long. So I'm going to stop here. I'll see you again in a couple of minutes.